We welcome you here on the board, sir, of LPU Online. You are, I think, on mute, sir.
Yes,
Yeah,
sir.
yeah.
Thank you,
Now,
sir. Thank you very
now
much.
it's okay.
Thank you very much.
As students in Hindi, if you talk about Manmohan means man ko
Okay.
moh lene wala. So I hope today's our session is going to be the same. That will be close to us, close to students also. So I welcome Dr. Manmohan Sharma. He was presently serving as
Thank you very much.
professor in the School of Computer Applications, Lovely Professional University. Sir is having a vast experience of more than 24 years in the field of academics, research, and administration, and been associated with different universities and institutions of repute. Professor Sharma has been awarded with his doctorate degree from Dr. B.R. Ambedkar University, Agra in 2014 in the field of wireless mobile networks. Sir is having an interest in wireless mobile networks, his PhD area, ad hoc networks, mobile computing, recommender systems, data science, as well as machine learning. He is having more than 50 research papers authored and co-authored, which are published in international and national journals of repute under his credit. He is currently around three PhD students and three PhD MPhil degrees has already been awarded under Professor Manmohan Sharma. He has guided more than 600 UG and PG projects during his service period. He worked as a reviewer of many conference papers and member of the technical program committees for several technical conferences. He is also actively serving several journals related to the field of wireless mobile communication and cloud computing as their editorial board member. He is also member of the various professional and technical societies like Computer Society of India, Association of Computing Machines, Cloud Computing Community of IEEE, International Association of Computer Science, and Computer Science Teachers Association. The board. Sir, I would like to brief you a little bit about our LPU Online also. LPU Online is right now having more than 5,000 students, in which we are having students of more than 25 countries with us. And we are offering different programs. One of the very popular program is MCA. So for our students, we had requested you to provide your insights into cloud computing, its components, business models, as well as collaboration and virtualization. We welcome you on the board, sir. And now, not taking much of the time between students and you, sir, now I hand over the baton to you. You can start the lecture, sir. Thank you, sir.
Thank you very much, sir. Thank you. My screen is visible?
Yeah.
Okay. So it's visible. Okay. So here we are going to take an insight about the cloud computing. And first of all, we look at the cloud computing, that what contents we are going to cover in that what is cloud computing, what are the various essential components of cloud computing, then what is the characteristic technology involved, then deployment models and service models and applications, and then we are going to look at the VMware hands-on lab. Okay, so this hands-on lab is actually one lab, we can say virtual lab created by VMware, on which we can perform different experimentation on the cloud computing related to virtualization. So let us start with the introduction. So first of all, according to National Institute of Standards and Technology, NIST, this cloud computing is we can say taken as defined as it's a We can say it's a model for enabling ubiquitous, convenient, on-demand network access to the shared pool of configurable computer resources. So what are these resources? In these resources, we have networks, servers, storage, applications, and services. And these services, these different resources are provisioned and released without any effort, without any kind of managing effort, or with the interaction with the service provider. Okay. So here, when we look at the cloud, what is this cloud actually? I think all of you heard about www. So www is World Wide Web. What do we call it? World Wide Web. So World Wide Web, when we are talking about this World Wide Web, okay, we can say it's a collection of various servers on the globe. There are a lot of servers, those are used to provide the different types of services, okay, in the internet. And this is called www. And when we connect all these servers, we create internet. The internet is created, so we should not confuse the internet with the cloud. So cloud is different from the internet. Okay, it's not, both are not same. Cloud is not synonym of the internet. Actually, what happens in the internet? What type of services are provided in the internet? It provides services related, provide the different types of services like website surfing service. That means you can access different types of services. Okay, but you can proceed or you can perform all the different activities on your own computer. Okay, so here it only internet can only serve, it can only serve, it cannot provide you the other facilities like processing. So what are the different facilities that a computer can provide you? It provide you processing, it provide you storage, it provide you uh, various applications. So what you need to do whenever you are doing the uh, when you are accessing a particular website, a particular application, particular website from the internet, in that case, what you are doing, you are using or open that particular website using your own processor or using your own browser that runs on your computer. Okay. Second, the website data first stored in your storage, and then you can open it, just like cookies are stored in your system. Then we cannot use the applications, those are stored on the server. Okay, we can only use the application those are available on our own computer. Like if I want to use Microsoft Word, Microsoft Office, then I need to install it on my system. Okay, I want to use Microsoft Word, I need to install it on my system. For that, I have to pay different things, different charges. First, I have to purchase this Microsoft Office. Then I have to purchase the license for that Microsoft Office. So then I have to install it on my system, and then I can use it. Okay. So we can say that internet cannot provide all these things, but the cloud computing provide all these things like network, servers, storage, application, and also the services those are provided by the internet. Okay. So here, when we look at this, uh, it this cloud computing just provides an alternative to the on-premises infrastructure. So whatever infrastructure we have created inside a campus, okay, we are just trying to convert it or trying to provide it using internet or on the cloud, on some place where all these applications and all these storage can be used. Okay, so these storage, processing, or applications cannot be available or not available on your system. You are just using these and on server or the cloud server, which is available somewhere, which is located somewhere else. Okay, so so if cloud computing, if we choose cloud computing, then you are not responsible as a customer. We are not responsible for purchasing any kind of hardware or any kind of software or application. Okay, in that case, the vendor or the cloud service provider is responsible for purchase every hardware, every software, or whatever charges or whatever expenditure done on the maintenance. So everything will be done by the cloud service provider. You are here only to use it. Okay. So in the cloud, we have a lot of different types of software or platforms are available which we can use. And this cloud model is actually a pay as you go model. Pay as you go model means when you use some service, when you are accessing some services or some application or some storage or anything, then what you are doing? You are just paying for that. I think all of you are using Google Drive. Huh? So this Google Drive is one kind of very, we can say very initial kind of cloud that provides you the storage. On Google Drive, we have 15 GB of space is provided. Okay, that 15 GB we can use for storing the files. We can store our pictures. We can store our photographs. We can store our videos. We can store different things, different items on that. So that particular 15 GB is freely available. But if your 15 GB space is full or storage is full, then you have to pay. You have to pay for rest of the, and the charges are available there. You can see the charges. You can look at the charges over there. Okay, charges are depending on the size of the storage. It will charge you. Okay, so now come back to the cloud computing definition. Here we can say it's a model. This cloud computing is a model that provides you ubiquitous. Ubiquitous means that where the services or the information is available everywhere. Ubiquitous means everywhere. Okay, so anywhere, anytime we can access the services. This is called ubiquitous. Okay, and it's very convenient. Why it is convenient? Because you need only to access a particular web page, and then you can start working on the cloud. You can log in into that, and then you can start working on the cloud. And it's very convenient. You don't need not to install any software on your system to work. Okay, you can just directly start working on the cloud without installing any application on your system. And again, second thing, if you want to work on a particular application, what you need operating system. And for that operating system, to install operating system, you need a hardware. So there are three layers. One is hardware layer. Then on that we have operating system layer. Then we have application layer. Okay. So these three layers are there. First, we need to purchase the hardware, then we install the operating system on it, and then we install application, purchase the license of the application, and then start using it. So your cloud is very convenient. It's a very when we use a personal computer or a PC or a laptop, we need to purchase it and then start using it after purchasing the license of operating system, after purchasing the license of application. Okay, but on the cloud, what we need to do, we need to just go to a particular browser, open the web page of that cloud service provider, start selecting the services which we want to use, and then start using the services. Okay, got it? So we can say it's very convenient. We don't need to do a lot of work on that. Next thing is it's on demand. And means if whatever we want, we can just access that particular services from the cloud. If that cloud service provider is providing the service, okay. Otherwise, we move to another cloud service provider that provides the same service which we required. Okay. And then here a broad network access is there. Broad network access means where we can access these services literally from anywhere. From anywhere, that means we can use this network, we can use the services of this cloud from anywhere. That means we don't require to sit on a particular computer on a particular place. Okay. And we can go anywhere and then access it. So all, but you need to connect to the network. Now next thing, this is the, so if we look at the logical part or the services part, this is the characteristics of that cloud computing world. When we look at the hardware part or the data center part, we can see that these are the various resources available in that cloud. So network, we can use network services, we can use servers, we can use storage, we can use applications, and we can use services that are stored on the cloud. And all these services are rapidly provisioned with a click. Okay. If you want to access like if you want to use Google Doc, what do? You just go to the Google Docs and then click on that, and your Google Doc will open in front of you, and you can start working on that. And if you want to, even you don't need to save the contents; it will automatically saved, and then when if you want to close that, you can release it or you can close it without any interaction with the Google or any Google service provider. So this is your cloud computing. Now come to the main components or the essential component of the cloud computing. Those here we can use. So essential components of cloud computing are abstraction and virtualization. What is abstraction? Abstraction in literally we call it hiding. Okay. So here when you are using Google Docs, say, so in that case, you are not aware about that on which machine this Google Doc is running or executing. So what is the hardware? What is the operating system? You are not aware about that. You have just an interface available on which you are working on the Google Docs. So this isolation of application from hardware and operating system. Okay, this is known as abstraction. So what we are doing, we are just hiding some details of the underlying operating system or underlying platform or the infrastructure, and you can only see the interface on which you are working right now. Okay, clear? So this abstraction is provided through virtualization. So here we are creating the virtual version of a particular computer resource or particular software that will be visible on your screen. Okay, and you are going to use that resource and perform different activities on it. Okay, and even virtualization is the thing which you can say that we can use multiple resources in virtualization, in virtual environment. Okay, so virtualization is, we can say we can create the virtualization of the software, we can create the virtualization of the operating system, we can create the virtualization of the computer hardware platform. Okay, so all, and the virtualization, when we create a particular virtualization, it can be shared by multiple environments simultaneously. So one environment, when we create a when we use a one environment or hardware environment, that will be shared between multiple users simultaneously or multiple types of different machines simultaneously. Okay. So what is the purpose? That we need to perform the administrative task, or we need to do the create the administrative task uh, in a centralized manner. Okay. So it will, so we can improve this, the scalability or the workload. We can easily handle all the workload. Those are available inside this virtualization. So let's look at the characteristics of the cloud computing. As we see there these characteristics inside the definition. If we look at the definition once again, so it's a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computer resources. These are networks, servers, storage, application, and services. Those are rapidly provisioned and released with minimal management effort or service provider interaction. So here, here in that particular case, when we are looking at the characteristics, all these characteristics are extracted from this definition. So first characteristic is broad network access. Broad network access means user can access the services from anywhere or using any device, whether you use mobile device or tablet or laptop or any desktop. Whatever you want to use, you can access the services of the cloud from these devices. So these devices are actually just used to connect with the network, and then we use one browser or any application, or we can say an interface of the cloud to access the services of the cloud. So it will provide you broad network access. Second thing is on-demand self-service. So on-demand self-services where user can have the can have all the services or can use all the services of the cloud when he or she demands it. So with a click, we can use any particular service without any restriction or without any interruption. Okay. So for that, obviously, for that we need to pay, and that once we use a particular service, we can go to the third characteristics, that is your measured service. That means all the services, those we demand or we use, okay, it will be measured according to the uses, and you have to pay for that. Okay. Now, next characteristic is resource pooling. What is this resource pooling? Resource, actually, cloud is not a virtual thing. Cloud is not a virtual, or we can say hypothetical thing. We are just creating a resource pool named as data center. We call it data center, where all the different servers or different physical equipments or resources are available. So all these physical resources are available, and these physical resources are used for providing the services to different cloud users. So we can also call it multi-tenant model. Multi-tenant model means where the multiple users can access the same device or same resource, okay, from particular web page, okay, from a particular interface. So according to the consumer demand, these resources are provided the virtualization or virtual environment to the different consumers. That those demands that particular resource. Next characteristics is rapid elasticity. So rapid elasticity means that all the services, whatever you want, like I am using a virtual machine, okay, and that virtual machines contains uh, 1 GB of RAM, 256 GB of hard disk, okay, dual core processor. So this is a virtual environment which is provided. Now I want to increase the RAM. If you are using a physical computer, a physical machine, in that what you need to do? You need to go to the market, then purchase the RAM, and then you find some technician and then insert the RAM into your system. But here what you need to do? You need to just do a click. Click means you have to select the option to increase the RAM and then increase your RAM from 1 to 2 GB, 1 GB to 2 GB. So in some clicks you can increase the RAM of your virtual machine. Similarly, if you want to release that 2 GB, okay. So what do? Just go to that particular option where you can release the RAM. You can again reduce the RAM from 2 GB to 1 GB. So now you have to pay only for that duration when you are using the 2 GB RAM. That means you have to pay for 2 GB. Otherwise, you have to pay for 1 GB only. Okay. So this is called rapid elasticity. Provisioning and releasing of the resources at very fast speed. So in most of the cases, this will run automatically, but you can also do it on demand also. Okay. So now come to the technologies those are involved in the cloud computing. Let's look at the technologies those are involved. First thing, we are using a web applications, we are doing the clustering, we are using terminal services, we are using application services, we are using virtualization, we are using hosted instances, and then hosted solutions. So one by one, we will discuss what are these technologies. So first we come to the web application. I think all of you are aware about the web applications. Those are used. These are the web applications. Those can run in your web browser. So these applications are used to exchange the information between the server and the client, or between two hosts on the internet. Okay. So here. You can see the most common type of web applications like shopping carts, e-commerce websites. All of you are using Amazon. Huh? In Amazon, all of you are using shopping carts. So when you are searching a particular product, so what you are doing, you are just typing the information over there, and then it will provide you complete list of that type of product, similar type of product. So searching and filtering, and then you can do the filtering also. Filtering means if you want a particular brand from that type of product, you can filter that particular product from here. Okay. So filtering can be done. You can do searching, you can do the filtering, and you can also perform the instant messaging. You are using WhatsApp or you are using messengers. So these messengers are used for instant messaging. I think all of you are using social media. News feeds are there, web applications are there. So these web applications are actually used by the consumer, and it will share the information, or we can say pass the information from one user to another user. These are web applications are used. Okay. So for creation of the web application, we have different types of languages are available, like HTML or PHP or different things. or JavaScript. Now, so web application actually used as the interface for the cloud. So every cloud service provider has its own web application. If you look at this, uh, like Microsoft Azure, sharing my screen one. Is it visible? So Microsoft Azure, my screen is visible now? Okay. Okay. So you can see the Microsoft Azure here. So this is the portal which is available for accessing the Microsoft cloud services. Okay. So if you want to try it, you can go to that particular Azure service and then you can start the Azure from here. It is asked for the sign up and this is the portal or this is the web application which is provided by the Microsoft. And you can just sign in into that and so in Microsoft you have to put your complete account here. So this is Microsoft Azure platform. So this platform is a web application that provides you only a particular area where you can start working. This is your Microsoft Azure cloud. Let it is started. So it show you different types of services over here. Why? Why it is? You can create your own account on this. Actually, I have used it after a long time. Mostly, I am using my. So it asks for the debit card or private card, but I'm not going to provide it right now. Okay, so this type of portal, once you are logged into that, once you sign up onto that, you can start using the cloud services. Okay. Now I am sharing my screen too again. Now it's visible. You can see the clustering over there. Okay. So clustering, this is the next technology which we have used in the which we have used in the cloud. What is actually clustering? We can say that clustering, it's a collection of interconnected standalone computer. What are these standalone computers? Standalone computers are where they can perform all the different activities of computing on its own. So we call them standalone, or sometimes we call them autonomous computers. Okay, so these autonomous computers or standalone computers, when connected to each other and they work together as a single machine, then we can say This is a cluster. So here you can see in the figure, you can see these all are the different standalone systems or standalone servers, and all these servers are connected to each other. Okay, so we can say this is a cluster. It's a cluster that forms, and these machines should not belongs to the same kind of configuration. They don't have not required to have the same kind of configuration. Okay, that means we can use a Linux machine. Sorry, we can use a Linux machine here. We can use a Windows machine here. We can use a Mac OS here. Okay, we can use other systems here. Okay, other types of systems here. So we can, but the main thing is that all these systems are having applications in it. Okay, so these applications are stored in in these servers, and whenever we require, whenever the client require this a service from the cloud, so one of the server will assign to that client, like one of the client is here. Okay, so client come to the head node just look at that which particular system is free right now, or which particular server is free right now. So what it do, it assign the services, assign the one server to this client. Okay, then another client come, then head node assign second server to the client. Okay, then third client comes and it assign third client to the server. Fourth comes, it assign fourth to the server to the client. Okay, so that means one by one it assign each and every server inside the cluster to the client, and this process is known as load balancing. That means once all the servers are busy, then head node will look at which particular server is less loaded. Okay, so that less loaded server will be assigned to the newcomer. Okay, new client. So this process is known as load balancing. Okay, and second thing, we are also this process is also used for fault tolerance. What is fault tolerance? If one of the server goes down, then the first client is assigned to this. So what it do? Whatever work is going on this system, say it is using one application, okay, where the data is stored inside the database. So what it do? It just copy this complete information or copy this complete activity and then move it to the less loaded server inside the cluster. So all the cluster will perform the same type of activity. That means they have a database available or they have some applications available. So all the applications and the database are same. Configuration may be different, but the database and the application are same in all the servers. Okay, and these and whenever there is a modification in one of the server, after some time in a particular duration, they share this information to each other. Okay, so that all the servers must have the same type of information. Okay, is it clear? So, so clustering is very important when we are working on the working with the cloud. Whenever we provide this, the clustering is very important for the load balancing as well as for your fault tolerance. So these two benefits are there. One is load balancing, and second one is the fault tolerance. And third benefit is high availability. What is high availability? High availability means if any particular, which I have told you, that if one of the system fails Okay. So this high availability ensure that your cloud will provide you all the different services without any interruption, without failing. Okay. So your services must be continuous. Okay. So that is known as high availability. This is the third benefit of the clustering. So load balancing, where it make the so you are switching the services from one system to another system, so that your load is balanced. Every server inside the cluster are or properly loaded. Okay, and fault tolerance is if one of the system goes down, then its activities or its data should be sent to or used by or migrated to another computer, and then that server will start serving the client without. So this we need to eliminate the single point of failure in that. Okay, these are the benefits of clustering. Now there is another technology is used inside the uh, cloud, that is called terminal service. What is this terminal service? Actually, when we are working on a particular computer, okay, every time it provides you a desktop service, but when you are sitting on a system, on a remote system, and you're trying to access some server, okay, or server desktop, then that particular service is known as terminal services. And one, you can also in the Windows, you can use this RDP or remote desktop. So this remote desktop is one of the type of service provided inside your Windows for remote connection. Okay. So when this terminal service is we can access it anytime, anywhere, anytime. So one system, if it is available on some remote location, then we can access it using this terminal service from anywhere, anytime. Yeah, RDP is an example of terminal service. Yes. Okay. So here, so RDP terminals, you can use it for the remote processing, remote control. Okay. The remote desktop protocol we can use. So this is the Microsoft's remote control, remote desktop protocol. Okay. So what we are doing, we are just it provides you a virtual environment in which you can access that server. Okay, and it's all the functions, all the services. So what we are doing, we are just uh, performing. Yeah, we can say it's a kind of service, so that we can access the server, okay, or its services on a remote computer. So whatever activity we are doing, like I want to save some data, so it will save on the server's storage. I want to process something, it will process on the server's processor. Okay. So same OS, same kind of application, those are running in the server can be accessed on this terminal service. Okay. So these are the different points, like we can access the system from anywhere, anytime. It's a single point of maintenance is your server where all the applications are stored, all the different services are stored, data are stored. So here we need to install this service only once, and we can use it many times. Okay, by many from in many PCs. Then it reduced license expenses. We need to install the application, or we can say if I want to use the Microsoft Office or any Adobe Photoshop, I need to purchase the license for the server only, and then I can access it on my remote computer without purchasing another license. Security is high because only using the username and password I can access, and only when your system or when the server is allow me to connect, so I can connect only There is one option is available in your Windows settings to connect your system remotely. Okay, so you can access it remotely only when your server is allowed you to connect. And then we can use thin clients. Thin clients means the clients or the devices which cannot have any kind of processing or storage capability. It only used to connect these devices to the internet. Okay, and through internet we can access that particular uh, server. So this particular technique we are using in the cloud also. Hardware is not no longer an issue because we are using a thin client here. If we are using a thin client here, okay. Similarly, desktop hardware has a longer lifespan. We can use it for a long time without any interruption, without any maintenance. So this is an example of terminal service like initially when we are using the mainframe servers. I think all of you heard about it. So mainframe servers are connecting with a lot of dumb terminals. These dumb terminals are where they don't have any kind of processing or storing capabilities. Okay, so these dumb terminals are only used when only use the services of this main server or the applications of these main servers. So if what this dumb terminal have, it has a screen or monitor, and then there is a very simple unit that used to connect the device to the keyboard, mouse, and network. So this device, which is used with the doesn't have any kind of processing capability, doesn't have any kind of storage capability. It only have the hardware that connects the keyboard or mouse, so that keyboard and mouse can be connected, or we can use the keyboard mouse with the screen, and it is connected to the network, so that it connected directly to the mainframe server. So whatever activity I want to do, like I want to run a program. Okay, I want to run a program. So this program is stored inside the mainframe server. Through dumb terminal, I can access to this program, and this program will execute on the mainframe only. Okay, this program can execute on the mainframe only, and the data which is generated during this operation, it is also stored on mainframe only. So processing is done on mainframe, storing is done on mainframe. Dumb terminal do all the activities on the mainframe only. And how the services are provided, if there are a lot of dumb terminals are connected to this mainframe, so it uses round robin scheduling. I think all of you are aware about round robin scheduling. What is this? This round robin scheduling is where we are dividing the time of the processor in time slots, small time slots. Okay, and the processing time, like I just create this a part here, a particular processing time, that means of 2 millisecond is provided to dumb terminal 1, then 2 millisecond processing time is provided to dumb terminal 2, then 2 millisecond time is provided to dumb terminal 3, then 2 millisecond is provided to dumb terminal 4, and so on. When it comes to 8, so 2 millisecond is provided. Once 8 dumb terminal completed its activity, then what it do? The control goes back to dumb terminal 1. If any processing is left for dumb terminal 1, then processor starts the processing for dumb terminal 1. Okay, for 2 millisecond it will perform the activity. If process completes the execution, it's okay. Otherwise, it stops it, pause it, and then move to the next terminal. Same process, same activity is done with all the dumb terminals. And once the last dumb terminal completed its 2 millisecond or time slot, then control goes back to the first one. So this is called round robin. Okay. So and we also call it time sharing. Okay. So sorry. So here dumb terminal, this is this activity or this characteristics is used by terminal server also. So terminal server is also connected with multiple, that means one server is connected with multiple servers, multiple terminal services. So your server will provide time slot to each and every terminal service and provide the services to these systems. Okay. So there is your terminal service. Now, in the terminal service, we discussed about the thin clients. What is this thin client? The systems which you are using, that means your laptops or desktop, these are known as thick clients. Why we call it thick clients? Because all these devices have their own capability to perform, to store, to process, and to perform any activity, to perform different functions, advanced computing functions. Okay. So these are known as thick client. Your laptop, your desktop, all these are the thick clients. But what are the thin clients? These are the thin clients are the computer that doesn't have very high-end hardware available in it. Okay. So it has a very minimum processing capability, very minimum storage, very minimum RAM. Okay. Only it requires that it will connect it to the network. Or network means I'm talking about internet. Okay, your device must be connected to the internet. So when it is connected to the internet, these are the different types of thin clients that doesn't have a lot of hardware is available in that. So what it do? When it is connected to the internet, it access the resources of server. So what resources are required? It requires application, it requires processing power, it requires storing. So these are the main things which we require. So everything will be done on the server. Okay. So on that device, we cannot install any application. We don't have install any kind of any high and processor or anything. In that particular thin client, we only have only that much processing power so that it can run an application like browser. Okay, browser, so that we can access the interface of the cloud. Okay, and then we can use that particular cloud for our activities. Okay, for different types of functionalities. So there mainly we divide this thin client into two categories mainly. One is software thin client and second one is hardware. Software thin client, first of all, what is hardware thin client? Where device where it is only used for connecting to the internet and running a particular small application or a cloud application. That's all. Okay. So that is your hardware. So and software thin clients are, these are the application which can run on this thin client. Okay, this could be a cloud interface, this could be a browser, okay, or this could be a terminal service. So terminal service or browser or a remote desktop, anything we can run on our thin client. So thin client only has sufficient hardware to run these type of application. Rest of the high-end application or high storage application we cannot run. Okay, on the thin client. So there are different examples of hardware thin client. Oh, this is voice thin client. This is developed by the Dell. Then or there is another thin client from Oracle. There is another thin client from Lead Tech virtual desktop system. There are some software thin clients are like X Window system, then terminal server services, Citric ICA, Sunray appliance link protocol, PC over IP, virtual network computing, web browsers. These are the different example of software thin clients. Okay. Now, next thing is application services. Next technology which is used inside that, we are using the application services. So application services are the different types of software services that are delivered to the client via the internet. A server can deliver to the client via the internet. And these services are provided, or these software are provided on demand of the customer. So when customer demand a particular software, this will be provided to the customer. Okay. And for that, customer don't need to do anything with the application. It only requested the storage, the installation, the license fee. All the expenditure will be, or maintenance will be uh, taken care by the cloud service provider. Okay. Here we are using one application server to store all these type of on-demand softwares. Okay, so on-demand softwares are stored in this application server, all the different types of application, high-end applications, business applications. So whenever client requires a application, so what it uses a thin client connected to the web server, and on the thin client, it can use a web browser or any uh, cloud interface, and through that interface send the request to the web server. Web server is a web server that contains the interface or web application of the cloud. Okay, so web application connected to the application server. Through web application we can access the application server or any application which is installed on the application server. So once we send the request, this is an HTTP request. Okay, so HTTP request sent to the web server. Web server look at that what data is required. If it is an application, so what it do? It send this request to the application server. Application server send back the application to web server, and web server opens this application in form of on the web browser or the interface of that on the client's system. Okay, so this is the complete process which is used inside any cloud for accessing the application. Next thing is the virtualization. So here we are going to learn this virtualization in detail. So virtualization is, you can say, it's a technology that creates the virtual representation of different uh, different resources. Like it can create the virtualization of storage, it can create the virtualization of servers, it can create the virtualization of networks, it can create the virtualization of services. So what service provider is doing? It provides the different services to the end user. And these are the different types of virtual resources those are provided to the end user. So here, if we can say that virtualization, what we are doing, we are just creating hardware, we are providing a hardware device as a software to the user, like a virtual machine. Okay, so that virtual machine, if I show you a virtual machine here, I'm using one virtual machine. Here you can see the VMware workstation. It's available. Okay. It's visible. I think my screen is visible. Okay. So when you open this VMware workstation, this is the player. You can see I have created around 4 virtual machines in it. Okay. I want to open this virtual machine like this. Now I am using Windows. Right now I am using Windows environment. Okay. And on this Windows environment, I have created one virtual machine for Kali Linux. Okay. So I am starting this virtual machine, and now I can see this virtual machine. Once this virtual machine is started, you can see the complete desktop of the Kali Linux on my Windows virtual machine, Windows environment. Okay. Now, what is the main thing is there? First thing, if I want to use Kali Linux with my Windows environment, if I want to use the Linux environment with my Windows environment, okay, then there are two methods. First method is I can create a dual boot system where on one portion, one partition, my window will run, and on another partition, my Linux will run. Okay. But what is the uh, disadvantage of that? If I want to run Windows, okay, then I cannot run Linux on my machine. Okay. If I want to run Linux, then I cannot run Windows on that. So if I want to switch between these two devices or these two environments, okay, what I have to do? I have to just switch over after shut down one of the operating system. But what is the use of this virtualization? Benefit of virtualization is I'm using Kali Linux. This is the Kali Linux. Now I am in Kali Linux environment. If I make it full screen, you cannot say that I am using a virtual machine. I think now it's visible to you. Huh? But if I don't want to switch, I just can minimize it just like an application. Okay. So here, this virtual machine will provide it to me as a software. I can run this virtual machine. I can run this hardware as a software. So here, this complete virtual machine will treat it as a software. Okay, clear? So let's shut down it. Otherwise, so now your virtual machine is shutting down. Now I can run any other virtual machine on it. So I can create one or two or three or four instances of the same virtual machine in that. Okay. So how many instances you need? You can use, you can create that much of instances of your virtual machine. Clear? Now, let's move back to the our slides. Yeah. So now I think my slides are visible now. Okay. So here to run a virtual machine, what we require? We require hypervisor, or sometimes we call it virtual machine monitor. Okay. So virtual machine monitor or hypervisor, what is this? It's a virtualization software that you install on your physical machine. Just like I have installed VMware player on my machine, and I am using this VMware player for running the for creating the virtual machine and for using the virtual machine. Okay, so we can say it's a software layer. This hypervisor is a software layer that act as intermediary between the virtual machines or the operating system or the underlying hardware of your host operating system. What is this host operating system? In my case, it is Windows 10. Okay, and virtual machine is your, I'm using a Kali Linux virtual machine. Okay, and on this I'm using a guest operating system of Kali Linux. So virtual machine I have created, and then on that I have installed one operating system of Linux. So on Windows I am running Linux. Okay, so here we can say that hypervisor is a software that uh, provide the access to the physical environment of your host machine. Okay, and we can run more than one virtual machine simultaneously on the same physical resources. Okay, clear? I can run multiple virtual machine on my system using the same resources. So these resources, these physical resources are shared. These physical resources shared between the machines. Okay. So just remove that. Okay. Now there are two types of hypervisor in cloud which we are using. Normally, we are using all the we are using a type 1 hypervisor or type 2 hypervisor. The hypervisor which you have currently see on my system, this is your type 2 hypervisor, or we call it hosted. Hosted means where there is a machine. Okay, on this machine we have complete hardware like processing power, then storage, then your RAM, etc., or network, etc. Okay, all these hardware are available, and on the top of this hardware you install one operating system. Like this operating system is your host operating system. Okay, on the top of this operating system you have different applications are installed. So these are the different applications we installed on this, and as an application we can install one hypervisor. Okay, so this is your hypervisor, or we can say virtualization software. Virtualization software. So this virtualization software could be your VMware workstation or VirtualBox. From this is a virtualization software from Oracle. This is a virtualization software from VMware. So we can use any of these virtualization software to create virtual machines on it. So we can create multiple virtual machines on it. Okay. So these virtual machine, like one is created for Linux, another one is created for uh, for your Mac OS. Okay. Another one is created for your IBM operating system. Okay, so these are the different types of virtual machines. Those are created on the same system. So we are running these virtual machines as an application. Okay, so on existing operating system, these virtual machines are running as a application. Okay, so we can run multiple operating system on a single physical hardware. Clear? Second, we call it type 1 or bare metal hypervisor. This is called type 2. Okay. Type 1 hypervisor is where there is a machine, okay, and you have all the different hardware like your processor, your hard disk, your RAM, and network, etc. Okay, and on the top of, we are not using operating system here. What we are doing, we are installing a thin layer of virtualization software here. Okay, that is known as hypervisor. Okay, so this hypervisor is a, we can call it a thin layer of operating system with limited operating system capabilities. Okay, but it is very efficient in connecting with the network, okay, and interact with the physical resources. Okay, so here this one is directly interact with physical resources and also connected with the network. So it has only one capability. That means once you install this hypervisor, bare metal hypervisor on a machine, you cannot have any desktop on the screen. Okay, you are not able to see any desktop on the screen. It's only available. What is available? You can only connect it to some remote machine. So what we do, we install ESXi on that, and this machine is connected with some remote machine. Okay, and this remote machine contains a virtual machine, or we can say hypervisor management software, or your um, hypervisor management software like VMware vSphere. VMware vSphere. Okay, so what this management software is doing, through this remote system, we can create the virtual machines directly on this. So here we are creating VM1, 2, 3, 4, 5. Okay, we are directly creating the VMware here. So example of this type of hypervisor is EXI. This is one of the uh, flagship software or flagship hypervisor by the VMware, and this EXI is mostly used in the Amazon Amazon EC2 services. Okay, EC2 services is based on this ESXi hypervisor, VMware ESXi hypervisor. Similarly, there are other hypervisors are also there from Windows. From Microsoft we have Hyper-V. We can use Xen in Linux. Okay, so these are the different hypervisors, bare metal hypervisors available. So what is the difference? That your hosted hypervisor requires one host operating system inside the physical on the top of the physical resources, but bare metal hypervisor directly installed on the top of the hardware. Okay, and it can be accessed by a remote system, and through management software like VMware vSphere, we can control this hardware ESXi hypervisor, and we can create the virtual machines on these hypervisors. So the advantage of this one is that there is a direct connect between the hypervisor and your okay, so it's asking. So we start with this. So this is your and bare metal hypervisor directly installed on the top of the hardware, and we can use it directly. Now there are different types of virtualizations. What is virtual? One is storage virtualization. then server virtualization, then network virtualization, desktop virtualization, application virtualization, and there are a lot of other virtualization like data virtualization. Okay, all these are the different types of virtualizations you can use. So first, we look at the server virtualization. What is this server virtualization? The same, the type of hypervisors, or we can say these are the server virtualization where we can use the server in a virtual form where we can install the hypervisor or bare metal hypervisor that runs directly on the hardware. Okay, and second one where we are running the hypervisor on the hosted host OS. Okay, so if we look at the server virtualization, it will provide you a terminal service through which you can access these servers or services of the servers. So here you can, in that server virtualization, you can see, which we have already discussed. Okay, we already discussed that there is no host operating system in between in bare metal, and there is host operating system in between the hypervisor and the hardware you can use. Okay, so host operating system is there, which we have already discussed. So now we move to the next, storage virtualization. What is this storage virtualization? If you look at these storage, all these storage are different. That means we are, what we are doing, we are using the different hard disk. It is the hard disk is just like that which you are using in your computer system, SSD or SDD. Okay, so all these hard disks are connected to each other so that they can be treated as a single storage pool. Okay, so these, all these pools, all these devices are connected together so that they can be treated as a single logical storage pool. So that is called storage virtualization. So if here the data is stored in different hard disks, but what client is thinking, what client is looking at, client is looking at a very big storage area or storage space. So it assumes that there is only one hard disk available where we can store the data. Like if you are working on Google Drive, when you are uploading your photographs, it will not tell you that where your data is going to be stored. Okay, on which particular device it is stored. Okay, on which particular hard disk, or on at which particular block your data is stored. Okay, so that one is isolated, that one is isolated from. So you can see a virtual storage over there that looks like a big, very big logical pool of storage. Okay, so this is on a storage virtualization. Next is the network virtualization. Like I am using my device, just we have seen the virtual machine of Kali Linux. So do Kali Linux can access my network? So through that virtualization software, Kali Linux can access my network, can access the internet